A, we're going to review decimal operations. Our content objective is students will be able to find the sum, difference, product, and quotient of decimals. Our language objective is students will be able to first explain verbally the essential steps of solving problems with decimals, and second, they will also be able to read decimal answers correctly. Why am I learning this? Well, it's going to be very important to know these skills for solving equations further down the road. So on that note, let's take a look at our first example here. It says negative 3 8/10 plus negative 10 27/100. The very first question you always want to ask yourself when adding or subtracting is, do we have more positives or do we have more negatives? Well, let's take a look. I have a negative here and negative here, which means all I have are negatives. So to answer that question, I'm going to say we definitely have more negatives. But the question is, how many negatives do I have exactly? Well, let's take a look. Well, the 3 8/10 are negative, so I'm going to write that down. But the 10 27/100 is also a negative. So altogether, I have a total of, let's see, 0 plus 7 is 7, 8 plus 2 is 10, carry the 1, 1 plus 3 is 4, 1 plus nothing is 1, bringing down the decimal. I have a total of 14 7/100 negatives. So I'm going to go ahead and write that in my notes. The next question is, since I've already taken care of the negatives, is how many positives do I have? Well, taking a look at my problem, I don't see any positives at all, so I'm going to go ahead and write 0. And notice I went ahead and also marked the negative. You want to do that right away. The second you can determine which one you have more of, you want to write down the sign. Now, the very final question is, how many more negatives are there than positives? At this point, we're asked to compare negatives and positives. And the way we compare is we find the difference between them, which means we are going to be subtracting. So I'm going to go ahead and subtract these two values. So just know that anything minus 0 is the same. So I'm going to go ahead and say that that is 14 7/100. So how many more do I have? Well, I have 14 7/100 more. So my answer is negative 14 7/100. Notice since I already placed a negative, I don't have to worry about it. I know that my answer is going to have that negative sign ready to go. Okay, on that note, let's go ahead and move on to our next example. For number 2, we have negative 4 15/100 plus 8. Again, the very first question is, do we have more positives or do we have more negatives? Well, looking here, I know that there are more positives. So I'm going to go ahead and write that there are 8 positives. Right now, I know my answer is going to be positive. Okay, whatever there's more of, that's what you're going to end up for an answer, sign-wise. The next thing is, well, I've taken care of positives. Now let's take a look at negatives. How many negatives do I have? Well, here I have 4 15/100 negatives, so I'm going to go ahead and write that down. Final question is, well, how many more positives are there than negatives? And again, when we're comparing these two, what we're supposed to do is find the difference. So I'm going to go ahead and subtract these two values. 0 cannot subtract 5, so I must borrow. This becomes a value of 10, this becomes a 9, and the 8 becomes a 7. 10 minus 5 is 5, 9 minus 1 is 8, and 7 minus 4 is 3. So how many more positives are there than negatives? I would say that there are 3 85/100 more positives. So my final answer is positive 3 85/100. Moving on to our next example. For number 3, it says 4 9/10 minus 14. What do we want to do first? Well, since we have subtraction, the very first thing I want to do is add the opposite. So let's do that. I'm going to go ahead and change this subtraction into an addition problem. And then the next thing I'm going to do is the opposite. So what is the opposite of a positive 14? A negative 14. Once I do this, just to keep things a little bit neater, I'm going to go ahead and rewrite it as 4 9/10 plus negative 14. Now it goes back to the same old question. Do we have more positives or do we have more negatives? Here I can see that we have more negatives, so I'm going to go ahead and write negatives first. There are 14 of them total. The next thing, since I already looked at negatives, is take a look at positives. How many positives do I have? Well, I have 4 9/10 positive, so I'm going to go ahead and write that below. So notice I went ahead and purposely made sure that the decimals are going to line up, so that when I'm asked how many more negatives are there than positives, I can easily go ahead and find the difference between these two values. So notice your decimal belongs right after the whole number. I'm going to go ahead and put a 0 as a placeholder. I'm going to find the difference. You can't do 0 minus 9. You're going to have to borrow. This will become a 10. This will become a 3. 10 minus 9 is 1, bringing down that decimal. 3 cannot subtract 4, so I must borrow. Makes this a 13. 13 minus 4 is 9. So how many more negatives are there than positives? I will say that there are 9 1/10 more negatives. So my final answer is negative 9 1/10. So now moving on to our last example before I have you try some on your own. Here we have 14 5/10 minus 15 21/100. And again, notice we have a subtraction problem. This tends to be the tricky one out of all 4 operations, so you have to be very careful. What I want to do first is go ahead and turn it into an addition problem. And the way that I do that is by first adding, which means I'm going to turn the subtraction into an addition problem. Second, I'm going to do the opposite of the following number. So this number here, I'm going to say the opposite, which would be a negative 15 21/100. And again, to keep things neat, I'm going to go ahead and rewrite the problem as 14 5/10 plus negative 15 21/100. Now it's the same old question. Do we have more positives or do we have more negatives? Here I can see that we have more negatives, so I'm going to go ahead and record that and say 15 21/100, and that they're negative. So now that I've taken care of negatives, I'm going to take a look at the positives. I have a total of 4 5/10 positives. And I forgot to mention, I'm sorry, the second you decide if there's more negatives or positives, you're going to want to write the sign right away. Otherwise, what often happens is you forget to write down the sign of your answer. So now that I've recorded my negatives and positives, I'm going to go ahead and compare how many more negatives are there than positives. And again, what we do there is subtract the two values. I'm going to go ahead and put a placeholder here with this, a 0 for a placeholder. 1 minus 0 is 1. 2 cannot subtract 5, so we're going to borrow. 12 minus 5 is 7. 4 minus 4 is 0. 1 minus 1 is 0. So how many more negatives are there than positives? I would say that there are 71/100 more negatives. So up here, my final answer is negative 71/100. So now what I'm going to have you do is go ahead and try the next few problems on your own. So notice here, please make this change on your notes. Your notes has a positive 13 9/10. If you can please change that to a negative 13 9/10. So now what we're going to do is go ahead and go over the answers. For number 5, the sum is negative 9 2/10. Number 6 is, the difference is 12 3/10. For number 7, the difference is negative 17 4/10. For number 8, the sum is negative 13 5/100. For number 9, the difference is negative 38/100. And last but not least, for number 10, the sum is 10 4/10. Now moving on to multiplying and dividing decimals. We have 2 simple rules, and please remember this only works for multiplying and dividing decimals. First rule, if the signs are the same, your answer will be positive. So here are a few examples. If your signs are different, then your answer will be negative. And again, here are some examples. Please take note that when you're multiplying and dividing decimal, it has nothing to do with if you have more negatives or if you have more positive. That is with addition and subtraction. When we're looking at multiplying and dividing decimals, all we do is ask ourselves, are the signs the same or are the signs different? And for my visual learners, something that I use are what I call math emojis. So here, if my signs are both positives, this would make a nice happy face because the eyes actually match. So I'm going to say my answer is positive. Well, what if my signs are different with a positive and a negative sign? Well, then this emoji would be sad. So my answer would be negative. For my third example, what if it's a negative and a positive? Again, this emoji would be sad because the eyes do not match. They are not the same. They're different. So that would be negative. And last but not least, what often confuses some students is what about two negatives? Well, let's take a look. Would this emoji be happy because their eyes match and they are the same, or would it be sad? You are right if you said it would be happy because the eyes do match, and so I'm going to say when you multiply or divide two negatives, your answer is a positive. So feel free to use either methods. If you are a visual learner like me, this would be great, but if you're fine with thinking if the signs are the same, the answer is positive. If the signs are different, it's negative. That totally works as well. So moving on to the next example, it says simplify the following. It has negative 8 and 6/10, and again, this means times negative 9. Well, first of all, I can see that the signs are the same, so I know that my answer is positive. If you're choosing to use the other method, you're going to say, okay, well, the sign, I have a negative and a negative, so the signs are the same. This would make a happy face, so my answer is going to be a positive. So please feel free to use either method, whatever works for you. So now what I'm going to do is multiply. I have 8 and 6/10 times 9. So I'm going to multiply 9 times 6 is 54. 8 times 9 is 72 plus 5 is 77. So I'm going to say that my final answer is going to be positive 77 and 4/10. Okay, moving on to our next example. Oh wait, before that I want to answer my question in a complete sentence. I'm going to say, I determined that the product is positive 77 and 4/10. Do you have to say positive? No, because the second you say the number, we know it's positive unless you specify that it's negative. Moving on to example number 2. So first we're going to ask the same question. Are the signs the same or are they different? They are different, so my sign is going to be negative. And again, for those who are going to use the math emoji method, you can say that there's a positive, then there's a negative, so this would be a sad emoji, and that's why your answer is negative. Now what I'm going to do is go ahead and multiply these two numbers to see what the product is. I'm going to do 8 and 9/10 times 3/10. A lot of you are going to want to write this 0 in. Please note, this 0 is not important. So if you don't have to write it like that. In fact, I highly suggest you write it like this. The reason being is sometimes you'll end up having to write a bunch of zeros and it's not necessary. So multiplying, I have 9 times 3 is 27. 8 times 3 is 24 plus 2 is 26. But before I finish, I must count how many decimal places there are. 1, 2. So I'm going to go ahead and move my decimal place 2 over. So my final answer is going to be negative 2 and 67/100. Okay, so my sentence frame would be, I concluded that the product is negative 2 and 67/100. Moving on to division now. So here it says 3 and 6/10 divided by negative 4/10. Again, you're asking that question, are the signs the same or are they different? In this case, the signs are different, so my answer is going to be negative, so I would mark that right away. Now, let's go ahead and figure out this problem. First of all, I want you to remember that a fraction is basically division. And the next thing I want you to understand and know is a lot of students ask me what number goes inside. In other words, which number is your dividend? Your numerator will always be the number that goes inside. Number that goes inside. Always, always, always. Which we refer to as our dividend. So I'm going to go ahead and write 3 6/10, and it's being divided by 4/10. So here we know that before we can divide, we need to convert this into a whole number. And the way we do that is we move our decimal one place over. If you've ever wondered why we can do that, what's essentially happening is we're multiplying both the dividend and the divisor by 10. So now I'm going to go ahead and bring my decimal up. 4 cannot go into 3, but 4 can go into 36, a total of 9 times. 9 times 4 is 36, with a remainder of 0. So I'm going to say that my answer is -9. Okay, moving on to our before I do that, again, I'm going to say I ascertained that the quotient is -9. So last but not least, for number 4, we have -6 3/10 divided by -9/100. You're asking that same question, are the signs the same or are they different? Here the signs are the same, so my answer is going to be positive. Now let me show you the division part. So here, now it's not a fraction, it's actual division. It's a problem written with this symbol for division. So a lot of students still wonder what number goes on the inside. In this case, the first value is the value that goes inside as your dividend. So I'm going to put 6 3/10 divided by 0 and 9/100. So please don't use the rule that the large number always goes inside, because that's not true. Okay, it's always your first value or your numerator. So now, since I don't have a whole number, I'm going to go ahead and convert that by moving my decimal 2 places over. So here, in this case, we're actually multiplying by 100. Again, that's how it works. So I'm going to go ahead and move my decimal up. 9 cannot go into 6. However, 9 can go into 63 7 times. I'm going to subtract. I get a remainder of 0. A lot of you are going to want to stop at this point. However, you have to be careful. Notice there's a 0 to drop down. So you're not done. How many times does 9 go into 0? You're going to say 0 times. So my final answer would be positive 70. But again, the most common mistake is students will write that it's a 7, and that is incorrect. So you got to be very careful. Now moving on to our next problem. Sorry, before I say that, I'm going to say I determined that the quotient is 70. Now go ahead and try the next few problems on your own. Okay, so now we're going to go ahead and review the answers. Please make sure that your answers on your notes matches the answers on the screen. For number 5, the quotient is 1 2/10. Number 6, the product is 3 741 thousandths. Number 7, the product is -5 400. Number 8, the quotient is -12. And for number 9, hopefully you weren't fooled. This is a subtraction problem, so you have to go back to, are there more negatives, are there more positives, and you have to add the opposite. So here I'm going to say the difference is -7 7/10. And that is it for today.